All right, guys, we're here today. We're looking at some claim evidence and reasoning, which is going to be a crucial and important tool and skill set for you guys to have, not only in the classroom, but in real life as well. Because after all, I am the best tennis player there is in the world. Number one. Mr. Ritter? Number three, maybe. Number four. I mean, honestly, it doesn't matter because he's not number one. All right. So we're going to get into this today, and we're really going to get back at that idea of me being the number one tennis player in the world and Mr. Ritter being another number. But let's go ahead and look at our key terms for this. We're talking about claim, evidence, reasoning today, guys, and we're essentially looking at these three things and what they are. And the hard part about this is that you're used to getting content or information, and it's this way, right? It's set in stone what it is. Well, these really are umbrella terms for things that we usually do in our everyday lives. So we're going to start out with a claim. And a claim is a statement and or idea that answers a certain question, all right? Meaning that earlier I stated that I was the number one tennis player in the world. That's my claim. I'm claiming that. I'm saying that, right? Meaning that is a claim. And when we're making claims in class, we need to be specific, and we need these claims to be accurate as well, meaning that if I was to ask the question, what is the temperature of a certain liquid, right, you would claim it's this amount, and you're not going to say about, right? It's about this much. Well, we want it to be precise and specific. And these can be opinion based. If I was to ask the question, like, what's the best chicken sandwich on the market right now? My answer is definitely going to be Popeye Spicy Chicken Sandwich. Well, Mr. Ritter's probably going to go with the Chick-fil-A, combo meal because he's more of a classic, and I like the spice. So this is really all coming down maybe to an opinion as well. And it's my claim. I'm claiming this chicken sandwich is the best, right? That's easy to do. We got to back that up though sometimes. So if we were to look at this example here, we can see that we have a person with a hat on and a person without a hat on. And we're asking the question, how many blocks are there? Well, if you stare at it long enough, you'll see maybe 3, maybe 4. I've heard higher numbers, right? But this is an optical illusion here. The fact of the matter is that these people are making claims. This person with a hat on says 4. The person without a hat on says 3. And if you really want to answer this, I mean, I think it really comes down to the definition of a block. Is a block 2D? Is a block 3D? Right? Is a rectangle a block? Is a square a block? Okay. And not only that, but there's also an optical illusion. See, one of these lines is actually going to another block per se, and your eyes kind of get caught up in it. So how many blocks are there? Well, it depends on how you look at it. But what matters is these two individuals here are making a claim. All right. That brings us to our evidence. Reminder, I'm the number one tennis player in the world. I never provide you evidence that supports I am. So I probably have a false claim. But in science, our evidence is going to be scientific data that is going to support the claim. And this data is data that you collect in the lab, or it could be data that it was collected somewhere else. But the important thing is it answers the question, how do we know the claim is correct? No, I didn't say true. True is a little misleading in science, meaning it's always that way. We do like to use the word correct a little bit more in science because it is more accurately portraying that instance. Okay, so we could also ask the question, how do we know this claim is true? We could use that, but we prefer to use the word correct. All right, and then we have 2 types of data and or evidence in science, and that's going to be the qualitative data and quantitative data. I know over here it says quantitative first and then qualitative, but over here it's the opposite. So I'm just going to refer to this image here on the right because it is going to explain what it means. Qualitative data is going to focus on the quality of something. And Mr. Ritter and I both love to drink our coffee. And if you were to ask Mr. Ritter and myself, how many cups of coffee do we drink on a daily basis? Well, I might answer, or he might answer through a qualitative form. I drink coffee every day. All right. But on the flip side, if we wanted to answer this question through a quantitative method, we could tell you how many cups we drink or how many grams of coffee we drink. And these are just two different ways. A lot of times your qualitative data is going to be in the forms of surveys, feedback and discussion, and also observations, okay? Meaning what you saw. We saw a red bird, right? But a lot of people like to think quantitative is numerical, which it is. But let's pose an example real quick. Let's say that I'm taking some data on a TV, and I have an old TV in my house, and I was to say that this TV is very old. Is that qualitative or quantitative? If you said qualitative, you're correct. That is quality. We're talking about the quality of the TV. The quality is old. On the flip side, though, could I make that statement about the old TV quantitative? If you said yes, then you're correct. I could say, hey, I have a 32-inch TV at my house that is old. Well, that just became two types of data. We have quantitative, which is 32 inches, and then we have qualitative, which is old. But let's get a little bit tricky here. You're thinking, oh, Mr. Hackler, Mr. Ritter, I know this. I know this. If there's numbers, it's quantitative. If there's no numbers, it's qualitative. How about if I pose the question, I have a TV from 1980 at my house? Even though that's not a question. I said pose the question. How about if I was to say I have a TV from 1980 at my house? Well, 1980 is a number. It's got to be quantitative. It's not quantitative because it doesn't deal with a measurement. It deals with the quality of it. The quality of the TV is from 1980. 1980 doesn't have anything to do with the TV besides the year that it was built. So 1980 would be a form of qualitative data. So these two forms of data are things that you guys are going to use on a daily basis. When you make your experiments here in the classroom, you'll be deciding if you want to use qualitative data or quantitative data. And honestly, it is something that is a little bit tricky. But remember, always quantitative deals with a quantity, while qualitative deals with the quality. Last but not least, we have reasoning. Reasoning is going to be explaining the question, why? All right, and this is where everybody gets stuck. But what's crazy is that we can really turn that question why into a because. And I already know that you guys are able to answer questions on worksheets with the word because. This is this answer because, right? And that is really why. But in science, we want to focus on scientific examples, which could be things you have seen or observed, or scientific rule, theory, fact, or ideas. So this is really like what we would call the content of support with science, meaning reasoning. We're supporting with science or supporting science with reasoning, okay? So we're going to run through an example here, and we're going to look at a practice example. So I have a video here, and we're going to watch it together about something a little odd about somebody.
I have evidence that proves my dad's a space alien. He speaks a weird language. He drinks.
Whoops, I'm going to start from the beginning.
I have evidence that proves my dad's a space alien. He speaks a weird language. He drinks green stuff. He says he's from Albuquerque. I'm not buying it. I mean, just look at him. And one more thing, he has a spaceship. The evidence doesn't lie. My dad's an alien.
All right, yikes, pretty scary stuff there. But let's go ahead and go back to this example, all right? Let's think about it. In the video, what is the girl trying to say or claim? Well, if you're trying to say that her dad is an alien, you're correct. That's what she's claiming in the video. Now, we got to pose the question, how does she know her dad is an alien? Well, we can see right here, he speaks a weird language, he drinks green stuff, he's from Albuquerque. I mean, just look at him, right? All those are forms of evidence. And in this case, they're actually all going to be qualitative evidence because they're talking about the quality of her dad. All right. Now, this is where it gets a little bit tricky. Reasoning. Why is her dad an alien? Well, her dad's an alien because he's an alien, right? Well, in this example, we really don't have any scientific ideas to rely on. So we can see at the bottom of this CER, claims up top, evidence in the middle, and reasoning on the bottom, we can see that the evidence doesn't lie. My dad's an alien, all right? She's just restating her facts, why her dad is an alien, okay? So this example is not the best, but it does use CER. Back to my idea of me being the best tennis player in the world, #1, and Mr. Ritter being, I don't know, something a little less. I never give you evidence, nor do I give you reasoning as to why I am the #1 tennis player in the world. So my claim isn't very supported, meaning it shouldn't be true then, and or correct. So here's more of maybe something more a little bit scientific. So let's take a few seconds here. I'm going to read over this example, and then we're trying to find where the claim is, where the evidence is, and where the reasoning is located within this. It says fat and soap are different substances. Fat is off-white and ivory is milky white. Ivory is talking about soap, of course. Fat is soft, squishy, and soap is hard. Fat has a melting point of 47 degrees Celsius, and soap has a melting point of 100 degrees Celsius. Fat has a density of 0.92 grams per centimeter cubed, and soap has a density of 0.84 grams centimeter cubed. These are all properties. Because fat and soil have different properties, I know they are different substances. Different substances always have different properties. All right. Now you're like, dang, that was a lot. All right. This is typically how we're going to be trying to be answering most of the questions that are posed here in the classroom. But let's start off with identifying a claim. And usually, if you guess right, the claim is first. So in this, they're trying to claim that fat and soap are different substances. So that is the claim, meaning what this statement is trying to persuade and or inform the reader. Now, let's pose the question for our evidence. How do we know fat and soap are different substances? Well, if you stated that fat is off-white, they're different in color, they're different in texture, they're different melting points, and they have different densities, that is how we know they are different substances. This right here is our evidence. Which of the two would be, of the evidence that is there, which ones would be quantitative? Well, give you a second. Quantitative would be the melting point and the densities. Qualitative would be the color of the substance and the texture of the substance. All right. And last but not least, we have a because, which is another form of answering the question why. And we can see that really at the end, our reasoning really comes in, and we make the scientific idea that different substances always have different properties. Meaning there are some substances that have the same properties, but they're not all the same, because if all the properties are the same, it is the same substance. So here we have a great example of how a CER can be used to inform a reader about a certain thing. And in this case, we were looking at fat, about the differences and or similarities between fats and soap, which we're really focusing more on the differences because they are different substances. So if you guys don't get anything else from this CER video here, just make sure that you understand a claim is trying to answer the original question. Evidence answers the question how, and we have two forms. We have qualitative and quantitative. And then reasoning is the because or why, and we're trying to support our answer with scientific ideas, theories, or facts. If you guys would, let's go ahead and take some time to look at our practice worksheets for the CER. If you would, I'd keep the video up to help you, because you are going to have to identify and write some of these CER questions. Hopefully you guys have, if you guys have any questions, please reach out to Mr. Ritter or myself, and we would love to help you guys. All right. Reminder, I am the best tennis player in the world.